Looking for a website or domain? Then check out today's sponsor, Squarespace. Hello everyone, hope you're all doing well and thank you for joining us for another video. Now, whilst flat earthers can't agree on a complete flat earth model, they do seem to have a general consensus that the earth is a flat plane and that the sun and moon circle above it whilst maintaining a fairly constant altitude. Although they can't agree on what that altitude is. The distance from the North Pole to the South Pole is about 11,800 miles, which would put a flat Earth at around 23,500 miles across. Now, if the Sun and Moon were hundreds of thousands of miles high, then they should be visible high in the sky 24/7, which obviously they aren't. Which sort of forces the claim that they are in fact much closer to the Earth, with general distances given of only around a few thousand miles.
The astronomers now teach that the Sun's distance from the Earth is from 92 to 93 million miles, whereas it is proved to be under 2,400 miles.
Even around 3,000 miles high though, the Sun should never set. If the Sun were above one edge of the flat Earth and you were at the other, 23,000 miles away, the Sun should still be 7.5 degrees above the horizon. When the Sun's above the equator, and if you're on the equator too but directly opposite, the Sun should be 14 degrees above the horizon at its lowest point, rather than having gone behind the horizon 6 hours previously. The other big problem though is what their angular sizes should be doing. When we view an object, we see an angular size, which is the angle across the object that we see based on its physical size in relation to its distance away. The physical size of the object won't change, but as we change the distance, then the angular size is directly affected. So if we have an object that is 5 degrees wide when it's 10 meters away, and we double the distance to 20 meters, then the angular size will halve to 2.5 degrees. If you're in Egypt when the sun is at high noon, it would be 3,000 miles away from you straight up, and has an angular size of half a degree. 6 hours later, when we see it set, it's now 7,000 miles away across the Earth's surface, meaning the Sun would then be 7,600 miles away from you, which is 2.5 times further than it was at noon, and so it should appear to be only 1/5 of a degree in angular size. But it's not. Both the Sun and Moon's angular size remain constant from one horizon right overhead and to the opposite horizon. Now, flat earthers have put this down to atmospheric magnification, claiming the Earth's atmosphere is magnifying objects more and more as they get further and further away, which causes them to always appear the same size.
But throughout the day, as you're watching it rise and go over you, and you can take pictures of it throughout the whole day, the angular size change is what you would expect with a sun about 93 million miles away. So unless on the flat Earth, unless on the flat Earth the sun is also 93 million miles away, there's nothing on the flat Earth that would match what we see in reality.
You understand how angle of incidence works? You understand
angle of incidence in refraction? Yes, I do. A change in density or temperature changes the refractive index.
And does that magnify an apparent size of something?
Does that magnify an apparent size? No, an angle of incidence doesn't magnify an apparent size of something.
So the sun does have angle of incidence due to refraction, correct?
Yeah, but a tiny, tiny, tiny amount until it reaches the horizon.
So that would change its apparent size as well?
No, it would not change its apparent size, because angle of incidence change doesn't change the apparent size of something, it changes the apparent position.
The first obvious problem with this, though, is why is it only happening to celestial objects? Why don't planes, birds, balloons, and everything else in the sky also stay the same size as they get further away? The bigger and less obvious problem, though, that I think exists is the problem of the shape of the atmosphere that would be required to magnify objects to such an extent. But since we're about to talk about the shape of atmosphere, it seems like an appropriate time to tell you about today's sponsor, Squarespace. Squarespace is one of the leading website creating and hosting services on the market. They have dozens of website templates to choose from that suit all needs, and the templates can then be extensively customized very easily to make your website look however you want. But Squarespace offers many more tools as well. You can set up a blog. You could add a scheduling system to allow appointment bookings. You could set up your own online store or even start a marketing email campaign for your subscribers. To start with a free trial today, head on over using the link in the description, squarespace.com/Dave McKeegan, and to get 10% off your first purchase, then use the code Dave McKeegan at checkout. Now, back to the video. When an object's angular size reduces as it gets further away, the angle with which the light from it is entering our eyes is decreasing. So when we magnify an object and we're increasing the angular size that it appears to us, we must be increasing the angle that the light is entering our eyes, which is done via refraction. This is where light travels through mediums of different densities, and as it moves between them, the change in density will cause the light to bend. Now, how much it bends depends on multiple factors, such as the difference in densities between the mediums and the angle with which the light is traveling relative to the mediums. Now, we can't change the incoming angle of light from a subject that's traveling towards us, which means we have to vary the angle of the medium, which in the case of things like a magnifying glass or a camera lens, is glass. If we shine light through a flat piece of glass, it will bend when entering the glass because it's moving into a higher density medium, but it will bend back by the same amount when it exits the glass. So the angle that the light is traveling remains the same, although its position has changed slightly. Hence, when we look out of a window, nothing gets magnified. However, if we look through a window at a very tight angle and then we open the window, the position of objects will seem to move slightly, but their sizes will remain exactly the same. For us to magnify something using refraction through glass requires the glass to be curved so that the light entering from either side will be focused inwards towards the eye. This creates the appearance of a greater angular size, which is why magnifying glasses always use curved glass. And crucially, the glass has to be convexed in order to direct the light inwards towards the observer. If it's concaved, it will cause the light to disperse outwards and objects would then appear smaller. And this is where the shape of the flat Earth atmosphere becomes a problem. Because we know that air density reduces with altitude, and the drop is proportional to the rise in altitude. Hence, people can work out what their elevation is above sea level anywhere on Earth based on their air pressure. But if the Earth were a flat plane, then the changes in density of air are also flat. Which, yes, would cause slight shifts in the positions of objects when they're at very low angles, but would have absolutely no effect on the angular size of an object because all of the light is being refracted by the same amount. To have any chance of magnifying an object with the atmosphere would have to have a convex curve to it. But we know the air pressure gradient is proportional to the altitude above sea level, which means the sea level would also have to have a convex curve to it as well. That's all before you factor in problems like that to create a 2 to 3 times magnification requires refraction levels far more drastic than atmospheric pressure gradients would allow. Mind you, the sheer presence of a pressure gradient at all causes problems for flat Earth, but that's a whole different topic. Now, a few people have actually made the claim, incidentally, in previous videos, that the moon does actually change in angular size, appearing larger at the horizon. This is actually false, though. This is in fact an optical illusion that's often referred to as the moon illusion, whereby our brains are tricked into thinking that the moon looks bigger when it's near the horizon, but in reality, if you measure its angular size when it's near the horizon, either by photographing it or even just holding up a coin at arm's length that almost covers the moon, and then repeat it later when the moon is high in the sky, it's still the same angular size. Interestingly, there have actually been studies done on the idea of using the globe itself as an atmospheric lens, because curved atmosphere bends light around it, so if you parked a telescope in space where the light was converging and looked towards Earth, then the light that it can see being refracted by the atmosphere would be giving a magnified view of the universe. Anyway, that's going to wrap it up for this video. As always, leave your thoughts in the comments. Once again, thank you to Squarespace for sponsoring this video, and don't forget to check out that offer with the link below. And while you're down there, if you haven't already done so, then please consider hitting the like and subscribe buttons, and then hopefully we'll see you in the next video.